Alright guys, so we are going to move on to now question 4. We're going to be moving on to a very important topic as well, and that is in fact the topic of geometry, angle geometry, a topic that somewhat gives students some grief at times because you have so many different properties that you have to remember. Now, this topic is not one of the most consistent topics on exam. It does pop up now and again, maybe like once every 3 years or once every 2 years, but the concept of angles will always be prevalent on an exam paper. So whether it be angle geometry or it be circle theorem or it be some other sort of topic, then it's going to still require the concept of properties of angles. So let's dive right on into this one here. So the diagram below has one pair of parallel lines which are PQ and MN, which you can obviously see from the diagram drawn below. Now, those two parallel lines are then cut by a transversal which intersects PQ at L. So therefore, we have this transversal line right here, pardon me, we have this transversal line right here that basically cuts PQ at L. So right here in this position, that is the point L where the red line cuts the PQ, and it also cuts the line MN at the point T, that is this position down here. So it intersects the both parallel lines at those two positions. Now, it also went on to say that given that the angle LNT is 28, and you can clearly see that the 28 is right here, given that the angle LNT, so LNT is 28 degrees, which is indicated there, and the angle, and LNT is an isosceles triangle. So what that means for us now is that when we are told that it's an isosceles triangle that is involved in our diagram, then we know that one of the main properties of an isosceles triangle is that the base angles are equal. Now, on the exam paper, I did in fact, well, I'm not sure if I indicated on the paper that the two lines that are equal are this line here and this one here, but you can see on the diagram here that those two lines are equal, which therefore lets me know that this angle here and this angle here will measure exactly the same. Now, in addition to an isosceles triangle having base angles that are equal, then we also must know that the sum of the angles in a triangle measures 180 degrees. So all those information are going to be crucial when it comes to finding the necessary angles to help us find what is it that you're asking us to find. Now, it went on then to say that we should calculate the values of x degrees, y degrees, and z degrees, and we should give reasonable geometric reasons, or give geometric reasons for each step of your answer. So we can easily find here that the angle x, then let me just reduce this a little bit here. Okay, so the angle x here can easily be calculated because we have to start our calculation process from the angle to which we are given, and the only angle that we are given here is 28 degrees, which is inside the isosceles triangle. So I can therefore start by stating that since LNT is isosceles, I can start by writing a little statement here. Since LNT is isosceles, then I can safely say that angle, and we're going to call the angle that is beside x, we're going to call angle LTN, angle LTN, right? Because this angle is very close to X. If I find the angle that is adjacent to X, then all I have to do is take that angle away from 180, and then I'll find the angle X degrees because they're at a point on a straight line. So since LNT is isosceles and the angle LTN, this is this angle right here, is then that angle is going to be equal to 180 minus 28, and then I'm going to divide the answer then there by 2. So 180 subtract 28, that's going to give me 152, and if I divide that by 2, then the angle LNT is going to be 76 degrees. So therefore, if I zoom this up right here, I can know that this angle is 76 degrees. And then I also know that this angle here is also 76 degrees as well. Alright, so this angle here is 76 degrees as well. Now, since that angle therefore is 76, notice that it's very much adjacent to the angle X. So I can draw a conclusion then and state that X is equal to 180 minus 76, which therefore is equal to 104 degrees. And so a geometric reason for that would have been that angles at a point on a straight line measures 180 degrees. So angles at a point, you can write a statement for that. So angles at a point, okay, angles at a point on a straight line equals 180 degrees. So that's my reason for that. All right, so that's how you would get that full marks there. Now, since we know that this angle is 104 degrees, that's now going to give us a lot more information we need to move us towards the angle Y. And so since that red line, that diagonal red line that I indicated earlier is a transversal, when a transversal cuts a pair of parallel lines, it usually forms what are called corresponding angles. So if you pay very close attention to the position where angle Y is, and we pay attention to the position where angle X is, they are in relatively the same positions, but they are on different parallel lines. So we can confirm that angle X is in fact equal to angle Y. So I can go ahead then and I can write here that angle X, let's just use this space up here, angle X is equal to angle Y, so angle X degrees is equal to angle Y degrees, which therefore is equal to 104. And so a very simple reason for that is that angle X and angle Y are corresponding angles. And so therefore we can safely conclude that corresponding angles are equal. Corresponding angles are equal. Corresponding angles are equal. All right, you guys would write out a better statement. I'm running out of space here, guys, but you get the idea. So that's the reason why angle Y is equal to 104. Now, the more angles that we calculate on the same diagram, it's going to be much easier for us to find any other angles that they might ask us for. Now, to find angle Z, it's pretty straightforward, because if you look very closely at angle Z and you can make a comparison with angle 28 degrees, notice that it tends to form what I call a Z angle here, right? So it forms a Z angle here, right here. Alright, and so therefore we can easily state that angle Z is equal to 28 degrees. And so the reason for that is that angle Z is alternate with angle 28. So we're basically going to say that alternate angles are equal. Alternate angles are equal. All right, so that is exactly what Csec would be looking for. And like I said, guys, when you're on your exam, you want to do a lot of markups like this. I believe it or not, when you have your diagrams with those little lines and those little sketches, the examiner will most likely appreciate a student who make these little jottings and these little pointers and these little arrows. That's how the examiner will get a clear understanding that you as the student knows what you are doing. So remember that in order for you to gain that 7 marks, you can't just state what the angle is, but you have to state reasons for each step towards leading you to your answer. So this is how I would expect you guys to answer this question. All right, so you want to tap a little bit more into your geometric rules, your geometric reasoning, definitely, so you can be more effective going forward. All right, so we're gonna move on then to question 5 here. And so what we're looking at now is we are finally getting to the integral part of the paper. We're going to be touching base on what is known as transformation geometry. Now, for question 5, we're looking at, given that the quadrilateral PQRS undergoes 2 separate transformations, where P is equal to 2, 1, Q is equal to 5, 1, R is equal to 5, 3, and S is equal to 4, 3. You are to draw the shape PQRS on the grid paper given. So this is just a very simple task where you're required to plot the points and connect the points using straight lines. So let's go right ahead and get that done. If you guys have not, or you are still struggling at this stage with plotting points, you definitely want to check out my coordinate geometry video. It does go through an entire detail explanation of the concepts of plotting points, understanding scales, and drawing shapes on the Cartesian plane. So for this one, we're going to rush through this one a little bit here. Now, I've already drawn up my Cartesian plane, so I'm just going to go ahead then and attach the values on the paper here. So for the position of P, I'm going to take 2 steps to my right and 1 step up. Remember that the first number here is X, the second number is Y. First number is X, second number here is Y. First number is X, second number is Y. First number is X, second number is Y. All right, so it's always going left or right, following by you moving up or down. So we're moving from the origin, which in this case is 2 to my right and 1 up. So from the origin where this blue marker is right here, I'm going to take 2 steps to my right. So that's 1, 2 to my right, 1 up. I'm going to be in this position here. Then I'm going to move towards 5, 1. So 5, 1, 5, 3. So 5, 1 is 5 to my right, 1, 2, 3, 4, 5, and up 3, or up 1 I should say. So 5, 1. Then we're going to go 5, 3. So I'm still right here, 1, 2, 3, 4, 5, and up 3, 1, 2, 3 in this position right here. And then the next one here is going to be, say here, 4, 3. So 4, 3, 1, 2, 3, 4, up 3, 1, 2, 3. So please ensure that you have your paper in hand as you are in fact watching me plot these points as well. So here, connect those 2 points there, connect right here, pardon me, connect right here. All right, then we're gonna connect these 2 right here, and then we're gonna get this sort of shape here. This is a trapezium. All right, a trapezium shape. All right, beautiful. Now it went on next, then once we plotted that point, it went on next then to say that transformation A is a reflection in the line y equal negative x. And it is also followed by, after it has been reflected in that line, then it's going to be followed by a translation by the vector negative 1, 5. Your task is to draw the images of PQRS after each transformation with the broken lines and draw the line y equal negative x. Now, for those of you who are unfamiliar with where this y equal negative x line is, the y equal negative x line, it runs through the second and the fourth quadrant. All right, it runs through the second and the fourth quadrant. So basically then what we have is a line that looks like this here. All right, I'm going to try to draw it as best as I can. All right, I don't think it's okay, so let's try to see. Oops, let's see if I can draw it a little bit. Okay, it's supposed to go through all the. All right, I think that's about it. Could be a little bit more exact. All right, I think it's not drawn perfectly because it's really supposed to go through all the quadrants. All right, but it's going to be somewhere very close. Oops, that's not working. All right, so I'm going to leave it right here. So this is the line. Let me see if I can draw it a little bit better. I'm going to see if I can draw it. I believe that's perfectly drawn. Wow. All right, so it's that, basically that's the line y equal negative x. Right, it's really supposed to go through all these little quadrants right here. So it's supposed to go through here and here. It's supposed to go through perfectly through those quadrants right here. Right, but it's not perfect because of the type of template that I have on my tablet. But pretty much that's going to be your line y equal negative x. So basically what's going to happen here is that this shape, that green shape that I've drawn earlier, is supposed to be reflected on the other side of this line. Now when it comes to diagonal reflection, it's going to be a little bit tricky. So what I prefer to do when it's not a reflection in the x-axis where the object goes from top to bottom, or when it's not a reflection in the y-axis where it goes from right to left, I tend to always feel like I want to move and work with the formula. Now, if you guys can check back your notes that I would have done, and if you guys have not checked out my reflection part 1 and part 2 video, which you're seeing the thumbnail on the screen at the moment, then you will find here that watching that video will give you a much comprehensive understanding of what is it that I'm seeing in this worksheet here. So if we can recall that if we have a random point and that random point is sent in or sent across this line y equal negative x, then usually what happens is that the points are going to interchange. All right, the points are going to interchange. So y will become x and x will become y, pretty much. All right, and not only are they going to be interchange, but they're going to interchange and the signs are going to change as well. So we're going to have negative y, negative x. All right, and you can check out the full tutorial on my reflection tutorial video that was posted maybe a few weeks ago, maybe about 3 or 4 weeks ago. So you can check that out. But let's get into it here. So we're going to take back the original points that we have, which was 2, 1, 5, 1. So all those points are going to go through this process here. So 2, 1, 5, 1, 5, 1, 5, 3, and I believe it's going to be 4, 3. I believe 4, 3. All right, and once we take these 4 points here, we're going to send them through this line y equal negative x. As you can see, there's going to be a flip of the coordinate values or the ordinate values and a change in the sign. So 2, 1 is going to become negative 1, negative 2. 5, 1 is going to become negative 1, negative 5. And 5, 3 is going to become negative 5, negative 3. And 4, 3 is going to become negative 3, negative 4. All right. And once you plot these points, you will find that the shape will land on the other side of the line. So let's have a look at it. Negative 1, negative 2. So we're going to go ahead then. We're going to see negative 1 to my left, and negative 2 down. So that's this position right here. Then negative 1, negative 5. So that's negative 1 to my left. 1, 2, 3, 4, 5. I think I kind of made a mistake and draw my coordinate, my answers in the position. So that's right here. Then we're going to have, let me just erase it from now because I think I need some space for it to be clear. So let's go back here. We know that when these points have gone through that line, we're going to get -1, -2, -1, -5, -3, -5, -3, -4. So now we know what those answers are. So we're going to plot them again. Let's go again. So -1, -2. So that's -1 down -2. -1 down 5. 1, 2, 3, 4, 5. So that's this position right here. Then -3, -5. -1, 2, 3. 1, 2, 3, 4, 5. That's this position right here. And -3, -4. 1, 2, 3. 1, 2, 3, 4. That's position right here. And if I take my green marker and I connect it here and connect this here, oops, connect this here, connect this right here, and connect this right here, you will find, notice how the shape goes across the line. So it takes a reflection across that line there. All right. Now, after it has been reflected, they then stated that the shape is going to actually be translated. So it's going to be followed by, here it is saying it right here, followed by a translation by the vector -1, 5. So if you want to calculate this, then all we have to do then is just add the vector -1, 5 to the answer. So -1, 5. All right. And so what that will give us then is that we're going to then add all the top numbers to -1 and then add each bottom numbers to 5. So if I add -1 plus 1, I'm going to get -2. -1 plus -1, that's also going to be -2 again. -3 plus -1, that's -4. And -3 plus -1 is also -4 again. If we go to the bottom then and we add -2, because remember this was 2, guys. Remember this was 2, so -2 plus 5, that's 3. -5 plus 5, that's 0. -5 plus 5, that's also 0 again. And -4 plus 5, that's going to be +1. All right, so if we go ahead now and we plot these set of new points, then you'll find that this green shape right here is going to be translated. All right, so then -2, 3, so that's -2 to my left and 3 up, 1, 2, 3, so that should be this position right here. Then we're gonna have -2, 0, so that's -2, 0 right here on the line. Then we're gonna have -4, 0, so that's also right here on this line right here. And then we're going to end up with, say here, the last one is -4 up 1. -4 up 1. So that's this position right here. And if I use the green marker once again, you'll realize that I'm getting the same sort of shape. Right here. Right here. And here. Alright, and that's the shape. So basically, this shape right here, let me get a different color ink. This shape right here got reflected and went across here. And after it got reflected, it got translated up here. All right. So this now is what we call a double transformation. All right. So it got reflected across the line y equal -x, and then it got translated towards that section there. All right, so pretty much, as I said, this particular question here, you can find 2 tutorials. That is, you can find the links to 2 tutorials that will give you a clearer understanding of what is it that I just did on this paper. And that would pretty much complete the question. Let us see if there's anything else that they ask us to do. They said that we should draw the images of PQRS after each transformation, which we have done. And we should also draw with broken lines the line y equal -x. We have done all that they've asked us to do. And so pretty much this is what you were required to complete. All right, so please do take the time out to check out my translation tutorial as well as my reflection part 1 and part 2 tutorial, which a link will be pinned in the comments below. All right, so let's move on then to another question. All right, now it continues then, and it says that we should determine the rotation metric for a 90-degree clockwise rotation, and once we have done that, we should then determine the coordinates of the object A -5 3 and B 1 4. Once you have determined the coordinates of those 2 points, we are to show the movement of this line on the grid paper. Now you can do this on a separate grid paper if you have it, or in this case I only have one, so I'm going to use the previous grid paper that I have around here to show you what that looks like. Now let's get into that question. Now if you can check out my rotation video as well, you'll see the thumbnail on the screen here. The rotation part 1 video will explain to you what is a rotation metric. And so a rotation metric, or the rotation metric for any angle of rotation, can be determined by the formula cosine theta minus sine theta sine theta cosine theta. All right, and please note that the formula that is being written here on screen is the formula for the anti or the counterclockwise rotation. Most times when rotation takes place, it takes place in a counter or anti-clockwise direction. So that's what you want to do. So this is going to be your anti-clockwise rotation formula. So you might then be curious as to what would be the clockwise rotation, because if this is the counterclockwise rotation formula, what then would be the clockwise rotation? Well, there's 2 ways in which you can go around this question. Now, number 1, you can go ahead and remove, say, the negative sign from here, and you can end up putting the negative sign, say, right here instead. So that would then turn the formula into a clockwise formula. Now, as opposed to doing that, notice that then if I go ahead and I keep my sign exactly where it is right then, if I put 90 degrees here, then that would just be a 90 degrees counter clockwise, but the question specifically stated that they wanted a clockwise rotation. So what you can do is that if you're going to use the anti-clockwise formula for 90, you then have to insert 270 degrees where theta is. All right, or you can simply remember to just change the position of the sign and put it here. So I'm going to just, this is because I like when things are simple for me, I'm just going to go right ahead then, and I'm going to just erase my negative sign from here, and I'm going to go ahead and put my negative sign down here and just insert 90 degrees. So I'm going to have the cosine of 90, and then going to have the sine of 90. I'm going to proceed to having the negative sine of 90. And then I'm going to have the cosine of 90. All right. Now, once I've done this, then I can easily calculate my metric. So that's going to be cos of 90 is 0. The sine of 90 is 1. The sine of 90 is 1, but the negative sine of 90 is -1. And then, of course, the cosine of 90 is 0. And then I can easily produce the rotation clockwise metric for a 90 degrees. All right, beautiful. So now that we have that down, like I said, you can review my rotation video part 1 and you will get a better understanding of how I came up with that formula. Now, it did use the transitional word or transitional sentence here, hence, which means that we're going to use what we just calculated to help us determine the coordinates of the object -5 3 and 1 4. So in other words, we're looking for the image of A after it has been rotated 90 degrees clockwise. So what we can do then is that we can go ahead and use the matrix that we've calculated here, and we're going to go ahead then and multiply this by the points that were given. So the points that were given were negative 5, 3. So negative 5, 3. And we're going to multiply then this by, say here, 1, 4. All right. Now, some of you guys mean, well, most of my students that are currently in my year group, we are in fact familiar with row by column. So if you go row by column here, then we're going to get 0 times negative 5, right? So this is matrix multiplication. 0 times negative 5 is 0, plus 1 times 3 is 3. All right. And then we're going to go row by column again. So let me just go down here. So we have 0, 1, negative 1, 0. And we're going to multiply that by the points negative 5, 3. You can do it one by one if you want to. And then we're going to go 1, 4 here. All right. So if you go ahead and we do our calculations here, you will find here that we're going to go row by column. So let's go ahead and do that. 0 times negative 5, that's 0, plus 1 times 3 is 3. Then we're going to go 0 again times 1, that's going to be 0, and 1 times 4 is positive 4. Then we're going to have row by column here. So we are going to have negative 1 times negative 5 is positive 5, and 0 times 3 is 0. Negative 1 times 1 is negative 1, plus 0 times 4 is 4. All right. This is the way Csec, I believe Csec would want you to do the calculation. So therefore, then remember we already know that this is A and this is B. All right. So then 0 plus 3 is 3. 5 plus 0 is 5. So that's going to be A prime. And then 0 plus 4 is 4. And negative 1 plus 4. Pardon me. 0. Okay. I think I made an error here when I said 0 times 4 is 4. 0 times 4 is 0. So therefore, negative 1 plus 0 is negative 1. All right. And that's going to be B prime. So basically then, the coordinates that they're asking for you, when they say that we should hence determine the coordinates of the object A, negative 5, 3, and B, 1, 4, we can safely then say that A prime is equal to 3, 5, and B prime is equal to 4, negative 1. All right. That's the way Csec wants you to do the calculation. This is just another neat way for Csec to ask you to do matrix multiplication. All right. So we're going to go ahead then and we're going to plot the points A, B, and then we're going to plot the points A prime and B prime, and then it should look like a rotation clockwise. So let's go ahead and plot A. A in the initial stage was negative 5, 3. So let's go on our graph, negative 5, 3. Let me grab a different color ink. Negative 5, 3. All right, let's use purple. That's good. All right, so negative 5, 3. So negative 5. It's going to be 1, 2, 3, 4, 5 to my left, up 3, 1, 2, 3. This is the position right here. And then the other point that we had, apart from negative 5, 3, we end up with 1, 4. So 1, 4, that's going to be 1 to my right and 4 up, 1, 2, 3, 4. So this basically would be the line AB. All right, that would be the line AB. Now, this is the shape that we want to rotate 90 degrees. So that means then when I go ahead and I plot the points that I've calculated around here, when I plot the point 3, 5, and 4, negative 1, then you should start to begin to see that 90 degree turn. So 3, 5, 4, negative 1. 3, 5, so that's going to be 3, 5, 1, 2, 3, up 5, 1, 2, 3, 4, 5, right here, 3, 5. All right, so 3 to my right, 5 up, and 4, negative 1, 1, 2, 3, 4, down, negative 1, boom, right here. You'll see when you connect this, you'll then realize that this point was rotated in this direction. Oops. So you'll then realize here that this point was rotated in this direction 90 degrees, and this point was rotated in that direction 90 degrees. All right, So that's the kind of understand, that's the kind of thing that you're going to be required to do most likely on your exam paper. Maybe you're not going to be required to do everything on the same graph paper, but you most likely will be asked to do something of that sort. All right, so I do have translation videos out, reflection videos out, rotation videos out. Should you find a problem or you're still a little bit perturbed by some of the things that is required for these concepts, feel free to isolate yourself and watch the individual videos that is related to this say here. All right, beautiful. Then we're gonna go ahead and we're going to move on to another aspect of the exam paper. Oh, sorry, I did forget this point down here. It says that we're to state two types of dilation, or otherwise called enlargement transformation. Well, there's only two types, and those two types are going to be a magnified dilation and a reduced dilation. Those are the two types of enlargement. When an enlargement is magnified, we call it a magnified enlargement or magnified dilation, and when an object goes through a reduction or it shrinks in size, then we call it a reduced dilation. So that pretty much answers that question then. All right, let's move on now to part A of question 5, or is that part B? I believe that's question 6, is it? I believe we did question 5A and 5B. So if, and this is 5C as well, so I believe this is question 6, I think. All right, let's move on then. So we're moving into the aspect of measurement. The diagram below represents a conical container with a capacity of 1,144 cubic centimeters, and we're also given that the height is 35. So therefore then, from that information, we are then asked to calculate some stuff. And so it says here that if the volume of a cone is 1/3 pi r squared h, then we should calculate the length of the diameter. Very interesting question, critical thinking question here. So we have to calculate the length of the diameter. Now, the good thing that I like about this question is that they gave you the formula for the cone, because usually CSET doesn't give you that formula. So let us start off with that. We know that volume of a cone, in this case, then we can just start with that. So volume of a cone, so V, oops, pardon me. So we're going to have V equals 1/3, so that's 1 divided by 3 multiplied by pi multiplied by r squared multiplied then by h. All right, and since we're told that the volume was 1,144 cubic centimeters, we then know that this is 1/3. We know that pi is equal to 3.142. Obviously, we do not know the radius, so we're going to leave that as r squared, and we know that the vertical height here is 35. So if we can go ahead then and we can say 1144 is going to be equal to, we can just go ahead and multiply all the top numbers. So we're going to multiply 1 by 3.42 times 35, and then we can divide that by 3. So let's go ahead and do that. 1 multiplied by 3.142, that's going to be the same thing as 3.142. So we're going to have 3.142 times 35. So let's go ahead and do that. 3.142 times 35. Let's go ahead and calculate that. Just a second here, guys. Give me a second here. Alright, so 3.142. Let's clear this screen here. 3.142. Oops, that's 3,142. 3.142 multiplied by 35. That's 109.97. So 109.97. Let's go back to our page here. So that's 109.97 multiplied by r squared divided by 3. Multiplied by r squared divided by 3. I'm just taking my time and doing it step by step. All right. So if we then go ahead now and we divide both sides, well, divide 109.97 by 3. So we're going to go ahead and divide this by 3. We're going to end up with 36.65. So 36.65 or 36.66. So that's 1144. 1144. Okay, pardon me. Jumping screens here. So that's 1144. Pardon me here, guys. 1144. And that's equal to 30 what was it? 35 point. Okay, it says 36.66. 36.66. 36.66 r squared. All right, now the only way we can get r squared to be by itself is to divide the 1144 by 36.66. 36.66. So that's going to be cleared. 1144 divided by 36.66. You find that we end up with 31.2. So that's 31.2. All right, so let's get to that here. So we end up that r squared is equal to 31.2. 31.2. That's 31.2. And so in order for us to find r, because we need to find r to find d, so to find r, we're going to take the square root of 31.2. And that's therefore going to give us, let's go here, square root of that number. Whoops. All right, so we're going to square root that number, 31.2. We get 5.58. So we can just call that 5.6. So therefore, r is equal to 5.6. Which we can safely say that d is 2 times r, so that's 2.5.6, which is therefore going to be simply equal that d is equal to 11.2. All right, 11.2 centimeter. All right, so I like this question. I really do like this question. It does bring out a lot of skill set that we should have, our transposition skill set, critical thinking skill, and the knowledge of linking the whole concept of diameter and radius with measurements. So that's really good. I like this question. All right, these are the kind of questions that Csec are going to send to you, or you're expected to get on May the 9th. Moving quite right along here, we have to determine the total surface area of the conical container, which is the shaded section, right? Now here's a hint down below that 1/3 the total surface area of any prism. Now here is where we're gonna have a little bit of knowledge, where we know that the total surface area, all right, total surface area of any prism is going to be equal to the curved surface area, plus 2 times the area of the top and the bottom. So it's 2a depending on if the prism has a top and a bottom. Now we first need to find the curved surface area of the cone. Now curved surface area of a cone has a special formula. Curved surface area of a cone is equal to pi r multiplied by the slant height. All right, and let me just double check on that. Let me just go on Google for a second and double check on that formula. I believe it's pi r multiplied by L. Let's check that out. So as we're looking here on Google, we're looking for the curved surface area of a cone, and you can see here that we've confirmed that it is going to be pi r times L. All right, so that's, and you can see the image over here as we're zooming up, that it's showing you that we're looking for that curved section around here. All right, curved section around here. All right, so we're going to look at that then. Okay, so we're going to come off Google here, and then we're going to go back to our document. All right, so it's always good to check. So the curved surface area is going to be pi, which is 3.14, times r, which we calculated earlier to be 5.6. And then now we're looking for the slant height. So the slant height would have been this height right here. Now we can easily find the slant height. We can find the slant height because if we get a chance to zoom up here, and here's where critical thinking comes into play. If we draw and we can let's say here that we project this 35 here, and then we connect a line like this. Pardon me, let's have it here. Let's connect a line like that. It forms a right angle triangle. All right, so what we're looking for is this height, which is the hypotenuse. We already have this height, which is 35, and we know that that length is the radius. We can use the Pythagoras theorem to help us with this question. So then we're going to have c squared is equal to a squared plus b squared. In this case, we are looking for the slant height, which in this case is going to be, let's just call it c squared for now. And then we know that a is going to be the vertical side, which is 35 squared, and then b is going to be 5.6 squared. So if we go on our calculator then and we do some mathematics, so that's 35. So that's going to be 35 here. Just a sec. So that's going to be 35 squared. So let's clear this. 35 squared. That's 1225. So let's keep that in our head, 1225. And we have 5.6 squared. 5.6 squared. 5.6 squared. Alright, so that's 31.66. And then remember we just calculated 1225. We're going to add those two together. We're going to get 1256.36. Let's just write that down. So that's going to be 1225 plus 31.6. Alright, let's double check on that. 1002. Okay, so give me a second. 31, sorry, pardon me. 5.6 squared, that's 31.36. We're going to add those together here. So that's going to be 1256.36. So then c is going to be equal to the square root of 1256.36. So pulling up the calculator then, add this to 1225. Good, that's what we have. We're going to find the square root of that, 1256.36. We know that the slant height is 35.4. Alright, so this slant height here is 35.4. Alright, so it's pretty close, so 35.4. Alright, so now we know the slant height is 35.4. We can then therefore go ahead and slip that value inside here, 35.4. So that's going to be 35.4. And then if you go ahead and multiply that now, 3.142 times 5.6 times 35.4. Alright, so let's see here. So we have 3.142 times 5.6 times 35.4. We're going to get a curved surface area of 622.87. So 622.87.87. Alright, and that is the surface area of the prism. Alright, very good, and that's it for that question then. Okay, So I think I kind of learned something, because if you notice that the hint that I have here is not exactly, that would not have given, I don't think it would have given me the exact value. I would have to check my answer sheet, but definitely what I've done here is exactly what needs to be done here, pi r times L. So that's going to be good information for us in the future. All right, now we're going to move to question 7 then. All right, and we're asked then to solve the equation below 2x squared minus 5x equals 7, and you're to leave your answer to one decimal place. Now, right away, as I stated earlier when we were doing question number 2 and we were identifying quadratic expressions, notice that it ends up with a square at the front here. So right away, I know that this is a quadratic equation. But I also recognize that with the quadratic equation, all quadratic equations must be equated to 0, and this question is equated to 7. So this means that I would have to transpose the 7 to this side, and then I'm going to end up with 2x squared minus 5x, and when I bring that positive 7 over, I'm going to have minus 7, and that's equal to 0. Now there's usually 2 ways to solve a quadratic equation. You can either use the factoring technique, or you can use the quadratic formula, which is also a formula provided to you by the examiner at the front of your question booklet. That formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, why would I choose to use this longer formula than the factoring technique? The mere fact that they said to me that I should write my answer in one decimal place is all the reasons that I need to know that this equation cannot be factorized. Well, sometimes you want to test it, right? Because as I'm looking at this now, it looks as if it can be factorized. So if you are better at factoring and the equation is factorable, then by all means go ahead and factorize. You might get to your answer faster. But I'm just going to go ahead then and use the opportunity to introduce this formula that I have done also on my channel, where I showed you how to solve any quadratic equation using the quadratic formula. So then we're going to end up with x is equal to, and we need to obtain the values of a, b, and c. Now, please bear in mind that a, b, and c, a is the number that is in front of the square, b is the number that is always in front of the x or the term without the square, and c is always the constant, the number that is all by itself. So once I have that information, then I can go ahead and proceed to interject those numbers into my formula. So then x is then going to be equal to negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c. So that's going to be 4 times a, which in this case is 2, times c, which in this case is negative 7, and that's going to be all divided by, 2 times a, and in this case 2 times a is 2 times 2. All right, proceeding then that x is equal to negative of negative is positive, so that's 5 plus or minus the square root of negative 5 squared. That's going to give us positive 25. Negative by negative is positive. 4 times 2 is 8. 8 times 7 is going to give us 56. Alright, so 8 sevens is 56. 4 times 2 is 8. 8 times 7 is 56. And that's going to be all divided by 4. Alright, so then x then will work out to be equal to 5 plus or minus the square root of 56 plus this looks like 81. 575, 81, so that's square root of 81 divided by 4. Okay, so then we move on then now to split up the factors. We're going to split up the answers. We're going to have x is equal to 5 plus or plus the square root of 81 over 4, or x is going to be equal to 5 minus the square root of 81 over 4. So we do a split. Alright, so x then is going to work out to 5 plus 9 over 4, or x is going to be equal to 5 minus 9 over 4. Now to bring this to the end, then x will be equal to 9 plus 5, that's 14 over 4, or x is going to be equal to simply here negative 4 over 4. All right, negative 4 over 4. So 14 over 4, it will work out that x is equal to 7 over 2, and negative 4 over 4, x will be equal to negative 1. All right, so that's pretty much how we are going to get the solutions to that equation. All right, and if you guys would also like a comprehensive review on how to solve quadratic equation, then you can by all means go ahead and check that video out as well. All right, moving on, then we're going to be doing some worded question here. The cash price of a computer is $12,480. The computer can also be bought on hire purchase by making a 25% deposit of the cash price, and you're also required to pay simple interest of 20% on the outstanding balance, which must be repaid in 18 equal monthly installments. We are to use this information to calculate the following. First, they want us to calculate the deposit required for the computer. Next, they want us to determine the outstanding balance. Third, they want us to calculate the balance to be repaid monthly installment. And I believe there's a few more questions around here. So we're going to take them down one by one. So the first question, right, is to calculate the deposit required for the computer. Let's go back to the information. It says that the cash price of the computer is $12,480. However, the computer can also be bought on hire purchase by making a 25% deposit. So to calculate the deposit required for the computer, that's going to be 25% over 100 of the value for the computer, which is $12,480. Now, if you want to do your own personal cancellation, you can, but since as we have a calculator, let's clear the screen. 25 divided by 100, I'm going to multiply that by $12,480, and you'll find that the deposit required will be $3,120. Very easy, yes? $3,120. Now it proceeds here to just a second. The question proceeds then to ask us to determine the outstanding balance. Now remember that once you take the computer out on a hire purchase deal, then what's going to happen is that the moment, what's going on here? So the moment you take out an item and you make a deposit, then you're still going to owe them. So remember that the computer would have naturally cost cash price $12,480, but because you made a deposit of $3,120, then the balance that you would have owed the company would have been the result of that difference. So therefore we're looking at, say here, $12,480. A second here. So $12,480 minus $3,120. So the balance to be repaid is $9,360. So that's going to be equal to $9,360. That would be the balance to be repaid. All right, simple question, but a lot of students, as I stated, have problems in interpreting this kind of question at the Csec level, believe it or not. All right, now the next part is the balance to be repaid, and the monthly installment, the balance to be repaid. Now be very mindful, because outstanding balance is the amount that is still owing after you have made your deposit, but the balance to be repaid is after they have added their interest, because you still owe them now. So they're going to add interest, and notice that they said here that simple interest of 20% is on the outstanding balance. So we're gonna increase that 9,000. We're gonna increase that 9,300 and what was that? $9,360 by 20%. So we're gonna have 20 over 100 multiplied by $9,320. Let's double check and make certain that that's our answer that we got. 9,360 or 9,360, not 9,320. Alright, so if you go on our computer then, sorry, not a computer, pardon me, I'm a little tired guys, but I'm pushing through to make this video a possibility for you. So 20%, 9,360, so that's 20% divided by 100 multiplied by 9,360, and then we're going to add that back to 9,360 because that is the interest. So the 1,872 would have been the interest added to the outstanding balance, which would therefore leave the balance to be repaid at $11,232. $11,232. $232. That's the amount that is left to be repaid. Now, again, guys, remember, outstanding balance is the amount that is owing after you've made your deposit. But remember that this is a business that the company is running. So if you're going to have a balance in the contract, you're most likely going to be charged interest on what is still owing. And based on this, they say that it is simple interest, which is 20% over 100 times the outstanding balance. Adding the interest now to the outstanding balance, then we would have ended up with $11,232. Alright, now they also want us to calculate the monthly installment. So if you go back to the question where they say that it must be repaid in 18 equal monthly installments. So therefore, the monthly installment is going to be $11,232, and that's going to be divided by, say here, 18. All right, that will tell us the monthly installment. So let's go back to our calculator here, and we're going to divide this then by 18. And so easily then, the amount to be repaid monthly is $624. All right, good. That's what is required then. Alright, and then now they want the higher purchase price. So bear in mind that the higher purchase price, let's go back to the formula for higher purchase. Higher purchase is equal to the deposit made plus, remember, higher purchase is equal to deposit made. Oops, let's fix this here. Higher purchase is equal to deposit plus installment times time. Deposit is higher purchase is equal to deposit plus installment times time. So we know that the deposit is what? The deposit is 3,120, and we're going to add that to the installment we know is actually going to be 624 multiplied by 18, which would have already have that value right here, which is 11,232. So there was no need to do any more calculations. 11,232, and so when we add that together, then 11,232, 11,000 plus 3,120. Remember that you made that payment down already. That's going to be 14,352. So that's 14,352. All right. So this will be the amount for the higher purchase. Higher purchase is equal to deposit plus installment per month times the amount of months. I would have already had that value from the previous question plus the deposit you paid down to take out the computer. All right, and so the interest that was charged was obviously going to be the initial cash price, well, the higher purchase price, which is 14,352 minus the original cash price, which is 12,480. So let's go back to the calculator here. 12,480. So we're going to minus that from 12,480, and so the interest that was charged was $1,872. $1,872. All right, so a tricky little question there in terms of if you don't understand the terminologies that is related to the question. As simple as it appears to be, it most likely will give students some grief as well. All right, and this question was extrapolated from a textbook. Usually CXC doesn't send it this complicated, but we don't know what they're going to come with, so we've got to prepare ourselves mentally. All right, and then bringing us to the last question of this paper, and also to the last part of this video. We are looking at a table. This is coming from, I believe this was a 2004 question. I don't quite remember, but let's have a look here. The cost of parking tickets at a car park in the city are as shown in the table below. Now, if you park your car under 30 minutes, you are going to get it for free. But the moment you go over 30 minutes, but less than 2 hours, you'll be charged $2.25 once you're stuck between 30 minutes and 2 hours of parking. Proceeding then is that if you go over 2 hours, but you're under 4 hours, you'll be charged $5.50. Again, as you go over 4 hours and up to 8 hours, you'll be charged $9.25. More than 8 hours and up to a whole entire day, you'll be charged $15 for parking. And if you purchase a 1 week ticket where you're free to park for however long you may choose for, you are going to be charged a total of $40. Now let's have a look at what's going on here. It says that Jordan leaves his car park at 6:30 in the evening, army time or soldier time as we call it. 18:30 would be 6 o'clock or 6:30 p.m. All right, so 1830 hours, and he pays $9.25. Now we are to determine the earliest and the latest time he can return for his vehicle. So since we know that he paid $9.25 here, we now can confirm that Jordan can park his car for up to 4 hours and no more than 8 hours for the money that he's paid. So therefore, at 6:30 in the evening, plus 4 hours, that's the earliest. So after 4 hours, he can free to come and pick up his car, right, to get the full value of his money. So therefore, at 6:30, with 4 more hours, then the earliest time that Jordan can pick up his vehicle is going to be 10:30 p.m. Adding 4 hours to 6:30, that's going to give us 10:30 p.m. But remember that the money that he's paid also allows him to park up to 8 hours. So at 10:30 in the night, he would have already parked for 4 hours, but he can park for another 4 hours, which therefore would have lead us up to 230 hours. So that's 2:30 in the morning, so 2:30 a.m. So therefore, the earliest time he can return for his vehicle is 10:30 p.m. and the latest time he can return for his vehicle is going to be 2:30 a.m. in the morning. All right. Anytime over that, he's going to pay more. Anytime less than that, he would have obviously gotten less than what the amount of money he has paid. All right. So 2 marks, not too heavy there. We're going to look then at if another customer parks for 8.5 hours, how much is saved if they had returned for the car a half an hour earlier? So at 8.5 hours, it means that a customer would have had to pay what? $15, because you can park for more than 8 hours, which 8.5 hours is over 8 hours, so that means you would have paid $15. But let us say that if the customer came for the car a half an hour earlier, then that would be 8.5 hours. So that would be 8.5 hours minus 5.5 hours. That would then reduce the parking time to 8 hours. So if you look at the calculation here, for 8 hours of parking, you'd pay $9.25. So the difference between the half an hour of parking is $15 minus $9.25. And if we do the maths, you'll realize that just a half an hour extra parking would have just saved this customer $5.75. All right, very, very simple question, but if you're not thinking critically and you do not interpret the table, then you will find it quite challenging to actually get this answer. All right, and then let's move on to the last question here. Shari Joe bought a weekly ticket and parked on 5 different occasions during the week. So already we know that since she bought a weekly ticket, I know that this is going to cost her $40. Now they're asking that how much could have been saved if she, how much, well, I actually made a typing error in terms of the language, but what I wanted to find out was how much is actually saved if she had bought separate daily tickets. So therefore then, for the first time she parked for 25 minutes. But remember, on the table, they say if you park under 30 minutes, it's going to be for free. So therefore, Shari Joe would not have paid any amount of money for her first parking. So she would have paid $0 for her first parking. For 7.5 hours, that's a little under 8 hours. So we already know that for the second parking, Shari Joe would have been charged. Let's check the table. Under 8 hours, up to 8 hours, $9.25. So for the second parking, that's $9.25. For the third parking, she parked 11 hours. So go back to the table. Let us see what is the price for 11 hours. It says more than 8 hours up to 24. So that's $15. So for the third parking, she would have been charged $15. And this is us looking at if she bought a single ticket. $15. For her fourth parking, it is 8 3/4. So once again, that's a little over 8 hours. She's again going to be charged $15. All right, and then for 6.25 hours, that is under 8 hours, she's once again under 8 hours. That's 4 hours up to 8 hours, and that's what we're looking at here. 6.75 hours. Okay, so that's going to be $9.25. So $9.25 then. So for the fourth parking, and then for the fifth parking, should have paid another $9.25. So basically this is $9.25 times 2 and $15 times 2, because the first parking didn't cost her anything. So it's going to calculator here. We're going to have 15 plus 9.25 plus 15 plus 9.25. And you can see that buying single tickets parking every day would have cost her $48.50. So this would have cost her $48.50. But because she bought a weekly ticket for $40, which would allow her a lot more parking time and more convenience, then by buying the weekly ticket, she ended up saving a total of $48.50 minus $40. She basically would have saved a total of $8.50. All right, and that brings us basically to the end of this exam paper. It has been a lengthy discussion, and like I said, guys, these are the type of questions for the first time throughout the year 2025. This is the first time I've structured a paper where I have not literally designed the questions myself. These questions were compiled and extrapolated from different past papers from 2004, 2005, 2007, maybe I believe 2014, and one question that came earlier up in the 2020s as well. So this was a nice little paper that really should allow you to understand the critical thinking required for the exams coming up in May 9. Now coming up on the channel, you're going to see a lot more of these types of paper. I have another exam paper to release sometime over the course of the weekend. I'm a bit stacked up and packed up with work, so forgive me if you're not seeing consistent upload, but I will make every effort to upload some exam papers for you to get you into that extensive practice mode. So with that said, I want to thank you guys for staying tuned with me for a little bit over 2 hours. I think this is about what, if I do the math here, it's about a little bit over 2.5 hours, because this would have been part 2 of the upload. So thank you so much for watching, and I really appreciate it. Continue to like, share, leave your comments down below, and I wish you all the best in your upcoming exams for the future. Until next time, take care. My name is Akin, your math instructor. Bye bye.